In this video, we're going to look at an introduction to Extrema and introduce the first derivative test. So what is an extreme point? An extreme point is a point where the graph of a function is going to change direction. If the direction is changing from increasing to decreasing, we have a maximum, and if we're changing from decreasing to increasing, we have a minimum. There are two different types of extreme points. There is the relative extrema, which is a max or min that occurs within an interval. So if I look at a snapshot of a function, I can say, okay, that is a minimum just for that interval, but an absolute extreme point occurs when there's a max or min within the entire domain. So here I have the graph of f of x equals x plus 2 squared minus 3. We see that we have a minimum here at -2, -3. Since we know the shape of this graph is a parabola, we know that this is the only minimum, so it is an absolute minimum. In the next graph, I have a quartic function. So here I see 3 points of interest. I have a minimum here, a maximum here, and then another minimum. -1, -2 is a relative minimum because it does change direction, but it's not the lowest minimum in my function on the entire domain. 0, 3 is a relative maximum, again, because it does change direction, but it's not the maximum point on the entire function. However, this last point here is an absolute minimum because it is the lowest point on this entire function within its domain. Okay, we're going to do a little bit of an exploration here between the function and its first derivative. So we're going to graph x squared minus 4 and its first derivative, and we're going to try to answer these following questions. For the function itself, over what interval are we increasing or decreasing? And what are the extreme points? So where are those max and mins happening? For the first derivative, we're going to look at over what interval is the first derivative positive, where is it negative, and then where are the x-intercepts? Okay, so for this exploration of a function and its first derivative, I'm going to use Desmos. And I have our function x squared minus 4. Now just a reminder, we're looking at answering these two questions: over what interval is f increasing and decreasing, and what are the extreme points? Okay, so looking at my function here, we see that we are decreasing from -infinity. Think about that x-axis as a large number line. From -infinity, and then we stop decreasing at x equals 0, where we now change direction. So that's an extreme point. And now we are increasing from 0 all the way to infinity. All right, so I made my notes here of what our questions were. Now let's look at the first derivative. So the first derivative of x squared minus 4 is the line 2x. Okay, and again, we are being asked to find over what interval is the first derivative positive, where is it negative, and what are the x-intercepts. Okay, so we see that we are negative here from -infinity all the way to 0, and we're positive from 0 to infinity. We notice that we have an x-intercept here at the origin. Okay, we're going to do the same thing with the next function. We have 3x cubed plus 2 and its first derivative. Okay, so looking at this function, we are increasing over its entire domain. So we don't see any change in direction, which means that there are no extreme points for this function. Okay, let's take a look at its first derivative, which is going to be 9x squared. Okay, once again, we notice that it is positive along its entire domain, and we do have an x-intercept here at the origin. Okay, in this example, we're going to look at 2x to the 4th minus 2x squared and its first derivative. All right, so we notice that we are decreasing until, and I'm just going to approximate here because to be honest, we'll see that for this exploration activity, being exact isn't really necessary. We just want to see how the function and its first derivative is relating. So anyway, we are decreasing until we get to about negative 0.75. Then we're increasing until we get to 0. Then we're decreasing until we get to positive about 0.75. And then we're increasing again. Okay, because we see those 3 different extreme values, those 3 different direction changes, we have extreme points. We have extreme points at negative 0.75, negative 0.5, at 0, 0, and then again at 0.75, negative 0.5. Okay, the first derivative of this function is 8x to the third minus 4x. All right, so remember here we're looking at where the function is positive and negative. So we are negative here from negative infinity to about, it looks like, negative 0.75. Then we're positive until we get to 0. Then we're negative again until we get to positive 0.75. And then once we hit there, we're back to being positive. Okay, we have x-intercepts at negative 0.75, 0, and positive 0.75. Okay, now we want to make some conclusions looking at this. So we noticed with x squared and 2x, it's decreasing the same place where the first derivative is negative, and it's increasing at the same place that the first derivative is positive. The extreme point at x equals 0 matches up with where the x-intercept is. That's where the change in direction is occurring. For 3x cubed plus 2 and its first derivative, we notice that it's increasing over its entire domain, and that shows with the first derivative. It's positive along its entire domain. There's no extreme points because there's no change in direction. We do have an x-intercept, and we're going to talk about more what that means, but that is what's called a critical value. It means it's a possible point where there could be an extreme value. But because of the nature of this cubic function, it ends up not being an extreme value because there's no direction change. Lastly, we looked at 2x to the fourth minus 2x and x cubed minus 4x. So once again, we notice that it's increasing and decreasing on the same intervals that the first derivative are positive and negative. And the extreme points occur where the x-intercepts of the first derivative are. So what conclusions can we make? Well, we saw that the function is increasing where the first derivative is greater than 0, and it's decreasing where it's less than 0. We also saw that if there are any extreme points, they're occurring where the x-intercepts are of the first derivative. This gives us the basis of the first derivative test. We use the first derivative test to find the relative extrema for a graph.